Welcome to the DIY Honda Garage channel. The following presentation addresses the Diagnostic Trouble Codes DTC P2252 and P2255 related to the Honda Odyssey models from 2011 to 2017. DTC P2252 pertains to the rear air-fuel AF sensor located in Bank 1, Sensor 1, while DTC P2255 concerns the front AF sensor located in Bank 2, Sensor 1. Both error codes indicate a low voltage condition in their respective sensor circuits, which can lead to engine performance issues. Resolving these codes requires a systematic approach to troubleshooting and a good understanding of the vehicle's fuel management system. This troubleshooting guide will help elucidate the components involved, their roles, possible causes of the errors, symptoms that may arise, and the step-by-step method of diagnosing these DTCs effectively. The Diagnostic Trouble Codes P2252 and P2255 refer to sensor malfunction in the air-fuel ratio system. The rear AF sensor, corresponding to DTC P2252, is situated in Bank 1 before the catalytic converter, primarily responsible for monitoring the air-fuel mixture that enters the combustion chamber to ensure optimal engine performance and emissions control. The front AF sensor associated with DTC P2255 is found in Bank 2 and performs a similar function. Both sensors play a crucial role in the vehicle's engine control module, ECM, by relaying information about the air-fuel ratio to minimize emissions and enhance fuel efficiency. Their locations in the exhaust system make them vital for real-time feedback on combustion processes, which affects overall vehicle performance. Understanding the possible causes of DTC P2252 and P2255 is vital for effective troubleshooting. A short circuit in the wiring between the AF sensors and the powertrain control module, PCM, can lead to low voltage readings. Additionally, poor connections or loose terminals at the sensor or the PCM can disrupt the signal, resulting in erroneous voltage readings. The air-fuel sensors themselves could be faulty due to wear or internal damage, which would also trigger these codes. Lastly, a malfunction within the PCM could affect its ability to interpret and respond to sensor signals properly. Each of these causes needs to be systematically examined to pinpoint the source of the issue. When DTC P2252 and P2255 are triggered, the vehicle may exhibit several distinct symptoms. One major sign is poor engine performance, which may manifest as rough idling or hesitation during acceleration due to incorrect air-fuel mixture ratios. This can also lead to increased emissions, resulting in potential failure during emissions testing. Additionally, owners may notice the check engine light illuminating on the dashboard, urging attention to the identified issues. Furthermore, reduced fuel efficiency may occur as the engine struggles to maintain proper combustion, leading to excess fuel consumption. Recognizing these symptoms can help drivers seek necessary repairs sooner, mitigating further damage. To begin troubleshooting DTC P2252 and P2255, first, turn the ignition switch to the on/2 position to enable the electrical systems of the vehicle. Next, utilize the Honda Diagnostic System, HDS, to clear the Diagnostic Trouble Codes. This step ensures that you are working with a clean slate and eliminates any old error codes that might affect your current diagnosis. Start the engine and hold it at 3,000 revolutions per minute, RPM, without load to simulate operating conditions, making sure to do this in either Park P or neutral N gears. This allows the radiator fan to engage, which can impact sensor readings. After approximately 2 minutes, let the engine idle, which is an essential step to gauge the system's behavior post-reset. After running the engine to clear previous codes, the next step is to check for any pending or confirmed DTCs using the HDS. This diagnostic tool will provide real-time data on any errors present in the system. Specifically, look for the reoccurrence of DTC P2252 or P2255. If either code appears again, it indicates that the issue is still active within the system, thereby requiring further investigation. Conversely, if no codes are present, it may suggest that the problem could be intermittent, meaning there might be loose connections or poor wiring that is temporarily resolved. Understanding the status of these codes is crucial for deciding the next steps in the diagnostic process. In this step, turn the ignition switch to the lock 0 position to ensure all electrical systems are disabled while you work. Next, jump the SCS SOVIS check signal line using the HDS, which allows you to run specific tests without interference from other systems. Following that, disconnect the A/F sensor, sensor 1, 6P connector to isolate the sensor from the circuit. Additionally, disconnect the PCM connector B, 49P, to gain access to the terminals necessary for continuity testing. This process prepares you for the next diagnostic step by ensuring that you are working on isolated components, which is essential for accurate testing. The next troubleshooting task involves checking for continuity between the PCM connector terminal B13, associated with the rear AF sensor, and body ground. Use a multimeter to measure continuity, ensuring that there is a proper electrical path from the PCM to the sensor. If you are checking B14, this is specific to the front AF sensor circuit. This test will help identify if there is a break or short in the wiring between the PCM and the respective AF sensor. If continuity exists, it indicates that the wiring system is intact, and further inspection should be focused on potential short circuits instead. Conversely, the absence of continuity would indicate issues requiring repair within the wiring harness, possibly necessitating physical inspection. Upon completing the continuity test and noting the results, you will want to reconnect the PCM connector B, 49P. Reconnecting the PCM is vital for resuming normal operations and further testing. Start the engine once more and hold the engine speed at 3,000 RPM, similar to the earlier diagnostic procedure, to ensure that the engine is under the same conditions as before. This action prepares the vehicle for a second evaluation of the sensor's performance. Allow the vehicle to idle for 2 minutes after reaching 3,000 RPM, giving the system an opportunity to stabilize and relay pertinent data to the PCM so you can monitor any additional DTCs or irregular behavior. In the final troubleshooting step, carefully measure the voltage present at the AF sensor, sensor 1, 6P connector terminal number 6, while the engine is running. This measurement will provide insights into the sensor's functionality and whether it is sending the expected signals to the PCM. Compare this voltage reading with normal specifications as outlined in the service manual. If the voltage is below expectations, it can further confirm the existence of a low voltage condition. If the voltage is within the specified range, it could indicate that the sensor and its circuit are functioning correctly and that the error codes may not be related to the components being tested. Proper voltage readings help diagnose whether the issue lies within the sensor itself or another related component. Once the necessary repairs are completed based on the troubleshooting procedures, it is vital to verify that the repairs were successful. Start by clearing the DTCs again using the HDS to reset the fault codes. After clearing, conduct a road test of the vehicle to observe its performance under typical driving conditions. Monitoring the vehicle after the test is crucial to ensure that no previously displayed symptoms are present and that the issue does not reoccur. During this process, keep a lookout for any new DTCs that may surface, which can signify follow-up issues that might have emerged. This verification step is essential for confirming that the repairs have effectively resolved the original problems associated with DTC P2252 and P2255. To prevent the recurrence of DTC P2252 and P2255 and ensure the long-term health of the vehicle, establishing a routine preventive maintenance schedule is highly advisable. Designate time for periodic inspections of the air-fuel sensor connections to ensure they are secure and free from corrosion. Additionally, inspect the wiring associated with both sensors for signs of wear or damage. Keeping connections and wiring secure minimizes the likelihood of disruptions in the electrical pathways. Regularly updating the vehicle's onboard systems can also help prevent sensor malfunctions, as updates can rectify software issues that may contribute to errors. Adequate preventive measures can greatly reduce the risk of future DTCs and maintain optimal engine performance. In conclusion, addressing DTC P2252 and P2255 in the Honda Odyssey requires a comprehensive understanding of your vehicle's air-fuel management system and structured troubleshooting methods. Recognizing the roles of the A-fuel sensors is crucial for diagnosing potential issues effectively. Following the outlined steps ensures that all possibilities are thoroughly evaluated, leading to a more accurate diagnosis and a higher likelihood of repairing the vehicle successfully. Additionally, being alert for symptoms will help in early detection and intervention. Lastly, implementing consistent preventive maintenance measures can minimize the likelihood of future occurrences of these DTCs, safeguarding both the engine performance and vehicle integrity. Please like and subscribe to the channel. See you next time.